I want to find the equation of the tangent line at this point. So that means I'm going to need to find the derivative, the slope, and I am going to need to find the equation line. So what am I going to do first? Well, the thing is, to find the equation of any line, and this is back from Algebra 1, we need two things. We need a point and we need slope. I'm going to use the derivative to find the slope, but the point's actually really easy, right? I have x here, I can find y. So I'm going to start by doing that, kind of get the easy stuff taken care of. And this was the first step on my list I gave you. So I would put x equals 3 into here. So then f of 3 equals 3 to the third, which is 1/27. So then my point here is 3 1/27. Okay. Now I've got this. I'm going to find the slope. Before I find the slope, though, I'm going to do something. I'm going to rewrite my equation, and I'm going to rewrite it like this. Why did I do that? Because now I can apply the power rule. Okay. So when I look at this as 1 over x cubed, I'm like, oh, that doesn't fit my rule. But as soon as I rewrite it as a negative exponent, I can clearly see how I can apply the power rule. So then f prime is going to be negative 3x. I subtract 1, so minus 4, or negative 3 over x to the 4. Neither of these is fine. Really depends on what you're doing with it, which one is more appropriate. Okay. Now, I need the slope at this exact point. So this is my general slope. This would give me the slope at any point. I want it specifically at x equals 3. So then I'm going to do f prime of 3, which is negative 3 over 3 to the 4th, which that's going to be 81. But then I can reduce, that's going to be negative 1/27. Okay. You can also see the 3's. This is 3 to the 1. You could have used your exponent rules to know that this is going to be that. So I could actually see that coming, but whichever way you want to go on that one. Okay, now I've got all my pieces, right? So this here is slope. This is my x1, y1. So now I'm going to use my good old point slope that I just love. Okay. So y minus y1 equals mx minus x1. So this is y minus, well, what was y1? Repeat. 1 to the, so this is 1 over 1/27 equals negative 1 over 27, because that, right, is my slope, x minus 3, because that was my original point. Now, it'll sometimes let you put it in there that way. I don't particularly like that. This is an answer. You've got the equation slope line, but I would like to be able to graph it. I'm going to rewrite it into slope intercept. So I'm going to start by timesing everything by 27 to clear the fractions, maybe make my life a little bit easier. 27y minus 1 equals negative just 1, x minus 3. So 27y minus 1 equals negative x plus 3. 27y equals negative x plus 4. And let's see where I'm at. I'm at y equals negative 1/27 x plus 4 over 27. So then this, both of these are the equation of the tangent line. I just like the bottom one a lot better because I think it looks neater, something I could easily turn around and graph if I needed to. So what were the steps to find the tangent line? Okay. And I'm going to actually come over here, and I have these in the notes, but I'm still going to go over them again right now. The first step is find the graphing point using the original equation. So what I mean by that is when we looked at the example that we had right here, okay, we put that into the equation as given. This one right here. This is our original equation, whereas this right here, this is our derivative, our y prime. Okay, so we're going to find the graphing point using the original equation. Then we're going to find the derivative. And obviously right now we're mostly using the power rule, but we're going to add to that. So then whatever it is, however you need to find that, this will give you the general equation for slope. So it's going to have an x in it. Now, there are some cases where you'll get a constant because the slope never changes. For instance, if you had a linear equation, slope never changes, you might get a number. That's usually not going to be the case, okay? Then you are going to find the slope at the given point. So this means to put in the value. In this case, this x equals 3. We put it into our general equation to find the point at that exact point. Because remember, most of these curves, the slope is changing as the graph goes on. So we want to find what's that instantaneous slope, what it is at that exact point I want. And then you're going to find the equation of the tangent line using point slope. Okay, so point slope is how you graph. I mean, you could do it other ways, but point slope is going to be your best friend. It's going to be the easiest way to do it. With the results from number 1 and number 3. Okay, number 2 was a stopgate that we used to get number 3, but then you're going to take it because you had your graphing point in number 1 and you have your slope in 3. And those are the things you're going to find that point slope to get the actual equation of the tangent line, which was your goal.